Okay, I will start with what we have done yesterday. So, this is the syllabus for module 2. So, we are doing this data representation and data types. So, I told you what is signal. It is a physical quantity that contains some information. So, we have two types of signal. One is analog and one is digital. So, analog signal is a continuous time signal which has a positive and negative value, and each point in an analog signal has some values. So, if we are sending the analog signal from transmitting end to receiving end, we will see lots of errors are there as each point has a certain value and it also has a positive and negative side. Whereas digital, we are either having a positive side or we are having a negative side, but here we are only showing the positive side. So we are having only two values, one is 1 and one is 0. So to at the receiving end we can easily correct the errors for this digital signal, because there are only two values, one is 0 and one is 1. So if we have a value of 5 volts, we are taking a value of 5 volts to represent 1. Even if at our receiving end, if we get like 6 volts or like 4 volts, we can easily say it is about 5 volts. So we can easily correct the error for digital signal. And for 0, if we are getting like minus 1 volt or we are getting plus 1 volt, then we can easily say it is near to 0 volt. That's why we can easily correct the error. So analog signal has a very low accuracy, and for digital signal we are having a very high accuracy, because the size of the files are very small, because we are only using 0 and 1 for digital signal. So some examples of analog signal are the voice voices which we are speaking, and the heartbeat is an example of analog signal. So why we are using a digital signal? Because it is a machine language and it is used by machine. So we are it is in a form of digital signal of zeros and one. So it is a common language for machine language, as a in the whole world we are using English as a universal language. So for machine we are using 0 and 1 for as a digital signal. So we are using 0 and 1. So the number of variables are very less. So the file is less. So our transmitting speed is more for digital signal. That is why we have advantage of digital signal. So some disadvantages of digital signal are that the system and processing is more complex, and as digital signal is having a higher bandwidth, so it so that is one of the problem, like we require a very higher bandwidth to transmit our signal. So what is the basic of digital signal? The basic of digital signal is 0 1. To study about this binary system, we will first come to know about what is decimal system, what is binary, and what is hexadecimal. This octal is not in your syllabus. Whatever we have read in our primary school, like decimal, so we have a number from variable, like we will say that variable. So we are having a variable from 0 to 9. So if we count these numbers from 0 to 9, we have 10 digits. So because the number of variables are 10 or number of digits are 10, so we have taken a base value of 10. So we might have studied like ones, tens, hundred. So what does it mean? Like ones means 10 to the power 0. So we will start with this right hand side, and we will start writing 10 to the power 0, 10 to the power 1, 10 to the power 2. And like that, we are writing some numbers. We will first start with the ones, then if it is completed, like from 0 to 9, and when it is completed, we will go to the tens. So same way, here we will do in binary. So the base value is 2 because we are having only 0 and 1 in this. So from in this also we will start from this right hand side. So we will start from 2 to the power 0, 2 to the power 1, 2 to the power 2, and like that. Octal we don't have to study, and after that we are having hexadecimal, which I will explain it afterwards. So it has 16 values, so our base value is 16 for this hexadecimal number. For explaining the binary number, I am just giving you example of decimal, how we are using. So it has 10 digits, so from 0 to 9. So we are counting 0 as a first term, that's why ninth is the 10th term. So we are having 10 number of digits. So, like for example, if we have a number 3,27,194, so how we will write it? So we will start writing from this side. For the lowest number, we will start writing 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, 10 to the power 4, and 10 to the power 5. So anything to the power of 0, it is always 1. So we will write a 1 here. So 10 to the power 1 is 10, 10 to the power 2 is 100, and 10 to the power 3 is 1000. Like this, 10,000 and 1 lakh. So how we are calculating this number? We are multiplying this 3 into whatever the value of 10 to the power is. And we are multiplying these two terms and then adding all the terms. So for this last this ones number, we will multiply 4 into 1. So we are multiplying 4 into 1. Then we are multiplying 9 into 10. So we are multiplying 9 into 10. Then for this one, we are multiplying 1 into 100. So we are getting 1 into 100 is 100. Then 7 into 1000, then we are getting 7000. Then 2 into 10,000. So we are getting 20,000, and 3 into 1 lakh. So we are getting 3 lakh. This then we will add all this number, and we will get a number of 3,27,194. Same this step also we will repeat in this binary number, but the only the thing will change is this base, because we are having 10 variables, we will change to 2 variable base as 2. So this is binary number system. Only two digits are there. One is 0 and one is 1. Okay. So as we did in this decimal, first we started from 0 to 9. Then after 9, all the digits they get finished. Then what we start? We start with again with start with 0 and put a 1. Similarly, in this binary number system, we will do 0 and 1. So all the numbers are finished. Then we will add a number over here. Then again we will do 0, 1. When both are getting 1, then we will add another third term and make it 0. Then we will do 0, 1. So this is finished. So like that, we are making a binary number. Okay. So yesterday I told you if the like each binary number is called as one bit, as we say digit in a decimal number system. In binary, for each digit we call it as a bit. We term it as a bit. So if our number of bit is n, then the number of combinations will be 2 to the power n. So why is that 2? Because we have two variables, 0 and 1. So if we have a number of bit as 1, then our combination will be 2 to the power 1. So there will be two combinations. So only 0 and 1 will come. So if we go in the decimal value, so 2 to the power 0 is 1. So we will multiply 0 into 0. Then we are getting a 0. And we will multiply 0 into 1. For the second term, we are getting a 1. So for two variables, our number of input is 2. Then 2 to the power 2, it will become as 4. So the different combinations are 0, 0, 0, 1, 1, 0, and 1, 1. So same way how we did for decimal, we will convert this binary into decimal. We will multiply this 0 into 2 to the power 0, so it is a 0. And we will multiply this also with 0 and add both. So we are getting 0. For 0, 1 will multiply this 1 to 2 to the power 0. So we are getting as 1. And here we are getting 0. So we are getting a 0. So 0 plus 1 is 1. For this third term, we will multiply 0 with 2 to the power 0, that is coming as 0. And we will multiply this 1 with 2 to the power 1. So we are 2 to the power 1 is 2. That's why we are getting a 2. For this third term, we will multiply this 1 into 2 to the power 0. So we will get a 1. And then we will multiply this 1 to this 2 to the power 1, where 1 into 2, we will get a 2. So 2 plus 1 we will get as 3. Same way we are doing with 3-bit numbers. So we will multiply this. I will just give you an example of this. So we will multiply 1 by 2 to the power 0, then we are getting a 1. We'll multiply this 1 to 2 to the power 1, we will get a 2. And we will multiply this 1 to 2 to the power 2, so we will get a 4. So this last number will be 4 plus 2 plus 1, so we are getting a 7 over here. The same with 4-bit numbers. So this 2 to the power 3 is 8, this 2 to the power 2 is 4, and 2 to the power 1 is 2. So our last term, 8 plus 4 plus 2 plus 1, it will come as 15. So this is how we are doing this 4-bit numbers. So there we will learn that this we have done. So what are the steps involved to how to convert this binary number to decimal number? So this is a binary number 1010. So what we will do, we will write this binary number, and then for in top of that binary number we will start writing 2 to the power from 2 to the power 0. So first we will write 2 to the power 0, then we will write 2 to the power 1, 2 to the power 2, 2 to the power 3. In any numbers are there, then we will write 2 to the power 4, 2 to the power 5 or something. And we will just multiply these two terms and then add it, and what is the decimal number we will get through that. So this is the steps. First, write down the binary number and list the power of 2's from right to left. Write down the digits of binary number below the corresponding two powers. So first we will write these two powers, then we will just below it we will write the binary number. Then if the digit is 1, write the corresponding power below the two below the line under the digit. Like if we are having 2 to the power 1, just we will just multiply it and then we will add it. So this is the step. Okay. Uh, there might be some confusion between hexadecimal and binary number. For hexadecimal, we are only taking 4 digits, but in binary number, don't confuse with that. If there are 8 numbers, don't write like 2 to the power 3 and then again start with 2 to the power 0. No, it will continue from 2 to the power 3 to 2 to the power 4. Okay. Like here in this example, we got a number 10110101. So we will write, we will start from 2 to the power 0, then we will write 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. So like for decimal, only 4 numbers are there, but you don't have to stop there. You have to again write after that. So write the values of what is 2 to the power 0. So 2 to the power 0 is 1, 2 to the power 2 is 2, 2 to the power 2 is 4, 2 to the power 3, like that you write the values and just multiply whatever the ones are with the number. So here first number is 1 into 2 to the power 0, so we are getting a 1. Here we have 0, so we will not use this term. Okay. Then this third term, we will use 1 into 4 or 1 into 2 to the power 2, and we are getting a 4. Then 1 into 2 to the power 4, so we are getting a 16, and 1 into 2 to the power 5, we are getting a 32. So we will add all these numbers. So 32 plus 16 plus 4 plus 1. So we will get a 53. So this binary number, so here we have base 2. That's why we have represented by writing a base 2. Like we have lowered it, means it is a base. And when we are converting it into decimal number, we are writing it as in base 10. So this is how we are converting this binary number into decimal number. This we did in last class. Any doubt in this? How to convert binary number into decimal number? So we will discuss about the data representation. So as I told, only one digit is there, either 0 or 1. So that is called a bit. Okay. If two numbers are there, then we will call it 2 bit. If three numbers are there, if we will call it 3 bit. But if four numbers are there, we give a special term. It is called as nibble. Okay. For 8-bit numbers, we call it as byte. So whatever the file size is, or the memory in the pen drive is, that is called bit. Like 8 GB is there, it means 8 gigabits are there. Sorry, 8 gigabytes are there. So that B is the byte. Okay. Even if I show you the file size, like for the file size for this, it is 299 MB. So this, what is this MB? That is megabyte. So all the memory we are saving, it is in this byte term, okay, or any memory. So that is in a byte term. Then kilo is 10 to the power 3. So 1024 bytes are called as, like it is 10 to the power 3, as 1000 is there. So that's why we call it as kilobyte. Then this is a megabyte, which is 1000 kilobytes, 10,024 kilobytes. Then gigabytes are there, and terabytes are there. So I think this is not in your syllabus. You have to only study about these three. So we already discussed about this nibble and byte. So bit is only one term, but if we combine 4 bits, then it becomes a nibble. Okay, so we can say a group of 4 bits, or if we convert into hexadecimal, which we will study later, so it is a single hex character, means hexadecimal character. Similarly, for byte, we can say it is a group of 8 bits, and another way we can say it represents 2 hexadecimal character. Then word is a combination of 16 bits, or we can say 4 hexadecimal character. And similarly, because this word is 16, if we double it, we will say it is a double word. So it is a group of 32-bit characters, or 8 hex characters. So you can represent it in terms of bits or in hexadecimal. So both you can write, like in the definition. This is just an example. If the notes comes, then how you can write it in form of words. But for this chapter, I think mainly the conversion part will come. Convert the binary into decimal, decimal into binary, or binary into hexadecimal, or hexadecimal to binary or decimal, like that. The questions will come like that for this chapter. So this you understood? Any doubt? Okay, thank you, Madan, Mahadevan, and Neeraj. So we completed this binary and this decimal part. So the next term is hexadecimal. Okay. So like we have to do some coding. Like we have to send some secret message. You might have heard of Morse code. There are some codes, okay, to send a secret message. Like that we use this hexadecimal numbers to make a very big binary number into small number. Okay. So we will study how we are making this big binary number into hexadecimal number. So what is the characteristics of this hexadecimal number? Uh, the hexadecimal means 16. So what is the base for hexadecimal number? We have a base of 16, which means we have 16 different digits. Okay. So first digits are from 0 to 9 and then from A, B, C, D to F. So here we can see we are having a digit from 0 to 9. And what we want to do, like we don't want to make this one digit into two digit. So what we do after 9, just remember, we are not taking two digits. That's why after 9, we are taking it as A, B, C, D, E, F. We want to avoid these two numbers. Okay. If we have to take these two numbers, we can simply write these decimal codes. So we won't use this decimal codes. That's why after 9, we start with A, B, C, D, E, F. Okay. So the base power of 16, based on the powers of 16. Okay, this is a little bit complicated if you try to directly convert from hexadecimal to decimal. So there are some steps we can do to avoid these problems. Okay. So what is there in this hexadecimal number? We are only having from 0 to 15. Okay. In decimal form, if we see, we are having only from 0 to 15. Okay. So here we are having 0 to 9 and from A, B, C, D, E, F. So if we write this in terms of binary, so what we will see, we will start with 4-digit numbers. Then what is a 15-digit number? The last four, like if we take 4 bits or one nibble, we can say what is the last number for 4-digit number? It is 1111. So that is the last digit of four digit bit number or a one nibble. Okay. What if we add like if we take 16, then what it will become? It will become 10000. So we want to avoid 16 because we are only need 16 variables. That's why we are only taking from 0 to 15. Okay, so we can see for using 0 to 15, we only use 4-bit numbers or we are only using one nibble. Okay, so what we will do, we will only take only 4-bit numbers. Okay, for hexadecimal, we will avoid all the other numbers like it is from 2 to the power 0, 2 to the power 1, 2, 3. So after 2 to the power 4, we will avoid it. We will only take from 0 to 15. Okay, this is what we will use to convert from binary to hexadecimal number. Okay, please.
Ma'am,
Yes.
ma'am, in hexadecimal, why didn't we take 10, 11, 12, 13, 14? Why did we take A, B, C, D?
Because in this coding we are trying to avoid two-digit numbers. Okay, if we want two-digit numbers, then what we can simply write 10, 11, 12, 13, 14, 15. Okay, so
Uh,
instead of that we are only using like A, B, C, D to avoid this two-digit numbers, avoid the confusion.
okay,
uh,
okay.
like if our what is our code, if I will give you example, like we have a code, okay, 4DD0. Okay, So if we see the table, so for 4 it is 0100, okay. Then it is D. Here we are having a D. So 1011. So what if we are writing as 13? If we write 13 instead of this D, then it will become two numbers like 1 and 3. So what is for 1? Then the code will become bigger, 0001, and for 3 it will become like then another one more term will be added, 0011. So like it, this binary number will become more. So that's why we are only trying to take a single digit number so that we won't have any confusion. Any other doubt?
No, ma'am.
Okay, thank you for asking the question. So, what is the primary function of this hexadecimal number? The primary function of this hexadecimal number is to what our binary numbers are very big. Okay, like it is a here we can say this is a small number we can easily evaluate, but in any if you open the file of any small file also for small photo, there are lots of binary number. Okay, so very it is very hard to like see what is the number. So we want to make that number very smaller. Okay, like example, you have an emoji. Why you are using emoji? Like you don't want to say like I am very happy or I am laughing or I am crying like that. So what you give a single emoji to make like communication easier, like you don't have to write that much. Okay, so you are representing through emoji. So same way, what we are doing, we are making this binary number into a very small parts, so that we will easily we will make that code very smaller. Okay, and one more example is there. What they do, like we are sending this message. Okay, we are sending this message for, but for some cases this zero changes into one. Okay, and one changes into zero. So what, there will be some error in the signal, like it is changing. So what they do now, they send this all the binary message, and they send this hexadecimal code. Okay, so what at the receiver, and what they do, they check this binary numbers, and if there is some problem, they check this hexadecimal code. Okay, so they check whether it is both are matching or not. If it is not matching, if it is changing from 0 to 1 and 1 to 0, and here we are getting a 4. Okay, so if 1000 is there, so the value will become as 8. Okay, but here in the code what they will see, that is not a 8, that is a 4. So they will convert this binary number back to 0110. So that is one more use of this coding, like to check the errors. Understood this part?
Yes, ma'am.
Okay,
Yes, ma'am.
to check the errors they can use this like hexadecimal coding. Okay, so for hexadecimal number, we represent it as a dollar sign, and at the end of the number, we add a h to it at the end of the number, like this, $64H. Like if we are writing a simple number, we don't write anything before that or after that. We assume it is a number. But if we are writing a hexadecimal number, it looks so similar. So how we will know whether it is a hexadecimal number or a normal decimal number? So what we do, we put a dollar sign and a H sign at the end. So we can know this is a hexadecimal number. Like how we will know which is a dollar, which is rupees. So dollar means currency. So we put a sign of dollar, we put a sign of rupees, or we put a sign of pound to represent different values of currencies for different countries. Same way for hexadecimal, we are putting a dollar and a H. Okay. So what are the steps to convert this binary to hexadecimal? So we are having a binary number. Okay, so we will start from this right hand side. We'll start with this right hand side. And you remember this table. What is there in table? We are having only from 0 to 15 and only 4 digits are there. Only 4 binary digits we are there. That's why we do, we uh, we make a group of 4 and 4 bits. Okay, so from this right hand side we will take 4 numbers, 1 2 3 4. So we will make one group for this. Then from after that we will again make it a 4 number, 1 2 3 4. Then we will make another group for this, either 4 bits or we will call it as one nibble. Okay, here it is written, divide the binary number into group of 4 bits, okay, or one nibble. So we will do that. We got a second term. Then we are going for third term. So it will be 1 2 3 4. We take the third term. And for the last term also, we will take 1 2 3 4. Okay. So there are 4 different nibbles. So we will see the values of each nibble. So for 0000, we will go to the table, and for 0000, what is the value in hexadecimal? It is 0. So we will write a 0 here. Okay. Then one more thing is there, like if we are converting binary to this decimal, it will become like very long. You have to do 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, like that. So many things you have to do. So what this will also become like very lengthy process. So what is easiest? Like we will directly convert it into hexadecimal, and it will be like a coding. Okay, so for this second term, second nibble, second 4 bit or second nibble, we'll say 1101 is there. So we will go to the table. We will see 1101. So what is the hexadecimal value for this? It is D. So we will write D for the second term. Then our third term is also same. And we will see the fourth term or fourth nibble. Then we will say 0100. So what is the value of 0100? We will see it is 4. Okay, so we will make it as 4. So what is the conversion of binary to this hexadecimal? We are representing it in a dollar sign and with an H. So it is $4DD0H. Okay, any doubt? Uh, we are once more, I will repeat why we are using only this 4 bit or one nibble, because last term is 15. Okay, and how we are representing 50? It with 1111. So this is the last term for 4-digit numbers. So that's why we are only using 4 bits, and there is no like 1000. Nothing is continuing after that. So we are only using 4-bit numbers. Okay. So here is one more example. If we get a number over here like this, then this binary digit. So here we divided it into 4 group, this into second nibble, this into third nibble, and this into last nibble. But here what we can see, we are having only one one. So we are having only one one. So like if I write from roll number 0 to 9. So if I want to write it into 2 digits, so what I will do, I will make it as 01, 02, or 09. And then after that 10, I will do 10. Okay. Same way, because our hexadecimal, it uses 4 digits, so we will just add 2 more digits over here. Or if it is 0 1, then we will like only 1 is there, so we will add 3 zeros to make it 4. Okay. Like whatever is missing, we will add those numbers to make it a nibble or 4-bit numbers. So for this number 1101, we will see the table. What is the value? It is D. So we will write a D. Then this is 0 0 1 1 1, second nibble. So 0 1 1 1 is a 7. So we will write a 7. This third nibble we will say 0 1 1 0. So 0 1 1 0, it is a 6. So we will write a 6 over here. The 6 is coming. And last is 0 0 1 1. So 0.
Ma'am, can
Hmm,
we add one?
pardon? Actually, uh, your voice is not coming properly. Can you repeat the question? Hello? Or
Yes,
you
ma'am.
can, what was your question?
Can we add 0 0 in that place 1 0?
No, you can't. Like, if you have a
Why,
roll
ma'am?
number 9, okay, you have a roll number 9, what you will add a 0 before it. You won't add 1 before it, na? 1 or 2. It will become 19. Okay. So, because 1 has a value, but 0 doesn't have a value before any number. After a number, it has a value. Okay. Like after any digit, like after 1, you put a 0, then it becomes 10. But before a number, it doesn't have any value. That's why we are putting a 0. Like you might have heard in a saying, na, you should add more number of zeros in your bank account. Like before, if you add the amount of zeros before any amount, that will become same. But if you add something after any number, it will just become into 10 times. That's why. Uh, See, over here, if I tell you, we have a value like this is 0, this is 0, okay, 0 0. So it has same value. It is also, this is also 0, this is also 0, and this is also 0. Okay. And if we have 0 1, like 0 1 is there, but if you are asking, can we add 1 over here, okay, instead of 0. So if we add a 1 over here, it will become 3. So that is the problem. But if we add 0, if this for this number 0 0 0 0 0 1, it is also a 1. So anything before a number is not it doesn't have any value. Clear? Like if you put a 0 before a number, like you have a number 9, and if you write 0 9, then it doesn't matter, it is still a 9. But if you write 1 9 or 2 9, it becomes 19, 20, 29, like that. So that will affect it. So that's why we can put anything before a number, it won't matter. So if we convert this hexadecimal number 64 in binary, and this 7f in binary, what is the value? See this table and tell me the value. 64 and 7f. Anyone?
0 1 1 0 0 1 0 0.
Okay, thank you. For 64, first we will see what is the value of 4. Okay, we will start with the lower side. So we will write 0, 1, 0 for 4, and for 6 we will write 0, 1, 1, 0. Okay, so the value for 64 it will become 0, 1, 1, 0, and continuing with that 0, 1, 0, 0. Okay, and for 7F,
Zero
0111.
one one
Zero
one.
one 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 one.
okay, thank you. So, by seeing the table, you can easily convert this hexadecimal number to binary number. Okay. So, but from seeing this table, you can even convert from decimal, hexadecimal to decimal, but it is little bit tough. Okay. Because hexadecimal is base 16 and this decimal is base 10. So the values will be little bit different. Like here it looks similar, but it is not. Okay, base 16 is there and base 10 is there, so that is different. So if you have to convert this hexadecimal number to this base number, okay, you do one thing. There are certain steps for converting hexadecimal to decimal. First, you convert this hexadecimal to binary number. Okay. Then from binary number, you do 2 to the power 0, 2 to the power 1, 2 to the power 2, like that. And you just convert it to decimal number. So here, how we will convert this 64 hexadecimal number to, by observing this table you will think it is same. Okay, but if we calculate it now, it comes totally different. Like we, I'll show you. So what are the steps to convert hexadecimal to decimal? First we will convert hexadecimal to binary number. Okay, if it directly comes in exam, like convert this hexadecimal number to a decimal number, first you convert it to binary number. Okay, then you, from binary number you convert it to decimal number. So we will convert this 60 $64H to decimal number. So this 64H, we will see what is the binary code for it. For 6 it is what we did, 0, 1, 1, 0. So we have written 0, 1, 1, 0, and for 4 we will see 0, 0, 1, 0, 0. For 64, the binary number is 0, 1, 1, 0, 0, 1, 0, 0. Okay, in the binary form. So what we will do from binary, what we will do for this, we will start writing how we converted from binary to decimal. So we will do the same thing. So we will write this term. Okay, we have written this term 0, 1, 1, 0, 0, 1, 0, 0, and we will start writing 2 to the power 0 from the right hand side. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Okay, and I am repeatedly telling you, okay, don't confuse this hexadecimal. Hexadecimal only has 4 digits, but this binary number, it can continue even from 2 to the power 7. It will continue 2 to the power 8, 2 to the power 9, like that. It will even continue from this. Okay, so don't take only 4-bit numbers when you are converting from binary to this decimal. So first we will write our this binary number, and we will write 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, like this till the end. Whatever the end is coming, till there we will write. Okay. Then what we will do, how we have done earlier, we will write what is the value of 2 to the power 0. So 2 to the power 0 is 1, 2, 4, 8, 16, 32, 64, and 128. Okay. So wherever we are getting a 1, we will multiply these two numbers. Or as it is in form of 0 and 1, you can straight away take these numbers, like whatever the number is, because anything into that number will be same. It will be equal to that number now. So you can straight away take this number. So we have written this first number and we have put the values for this base 2. So we will see where our ones are coming. This is 0. So this into 0 will be 0. This into 0 will be 0. So our this term 4 into 1 will be 4.
4.
So this, any problem? So this will also be 0 and the 16 will also be 0. Okay. But we are getting a 32 and a 64. So wherever we are having a 1, we will add those numbers. Okay. So we will add 64 plus 32 plus 4. So what is 64 plus 32?
96.
Good. Plus 4.
100.
So what is the value we are getting? Decimal value 100. Okay. But if we see 64 in this table, okay, if we see 64, we will straight away say that we are getting a 6 and 4. But this is wrong, okay? Because here the base is 10 and the base is 16. That's why. So don't confuse with that. We cannot directly write this 64 as 64 in the decimal. So first we have to convert to binary and then we have to convert it to decimal. Okay. So for this we have to the second term 7f. So what is our 7? 7 is 0, 1, 1, 1. So we have written 0, 1, 1, 1. And this f is it is 1, 1, 1, 1. So we have written 1, 1, 1, 1. Or here we have written 1, 1, 1, 1. Okay, so we have to convert this to decimal. So first we are converting into binary. So we have written it as a binary. We will write this from here. We will write 2 to the power 0, 2 to the power 1, write all the values and see only what are the values for this. Okay, so we will add wherever we are getting a 1. So 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. So after adding all these numbers, we will see we are getting a 127. Any doubt? And if we directly try to convert from hexadecimal to decimal, see, we are having 7f, okay? So we have to write a 7 and a f. So what we can write 715. But 1 is also having a different code and 5 is also having a different code, okay? So this will become 715, which is totally wrong. This will become a 715, which is totally wrong. So that's why after 9 we are using a b c d e f e f, because this 10 it has a different value. If you see 10, it has a value of 0001 and continuing with that 0000 0001 0000. Okay, that's why after 9 we are using a b c d e f. Any confusion? The doubt is cleared why we are using A, B, C, D, E, F.
Yes, ma'am.
Thank you, Neeraj. So here in book it is written very randomly. So I will just I have put it in the points. Advantages of hexadecimal over binary. Okay. So the what is the disadvantage of binary? Like binary is a very large number and very inconvenient to handle. That's why we convert it into hexadecimal, because that numbers become very small, okay, and the file size will also become very small because of that. And this hexadecimal we can use in error correction, because the very big numbers are becoming very small. That's why we are using this hexadecimal number over binary. So what is advantages of hexadecimal number? So remember these points. Okay, this can I don't think this will come in the exam, but it is there in the book. these points. For this chapter, mainly this conversion part will come. Convert this binary into hexadecimal and hexadecimal into binary. This thing will come. Okay. So, what are the advantages of hexadecimal? It is easy to comprehend or easy to use. Offers advantages over decimal number. Like this is also a type of machine like coding. So that's why it has an advantage over this. Denary means decimal or base 10 numbers. Third point is conversion of binary to hexadecimal and vice versa is very easy. Like you cannot convert this hexadecimal direct. There is a way, like EC people, they will study in the advanced stage in second year, I think, how to convert this hexadecimal to decimal directly. But no need to study, means no need to go that much in depth. So just what we will do, we will make a table for binary, we will make a table for decimal, this table. First you write the decimal base 10, make write 1 to 15, then write binary 1 to 15, and then do write hexadecimal 0 to F, and through this table you try to convert it. Okay, and don't convert hexadecimal directly to decimal, it will be wrong. So convert hexadecimal to binary, then binary to decimal. Or if you have to convert decimal to hexadecimal, then do the same thing, decimal to binary and binary to decimal. Okay, because if you write directly it will be completely wrong, because it has a different value. It's easier from decimal to binary and binary to hexadecimal. A single hexadecimal character range from 0 to F represent 4 binary digits, which we have done. We are taking 4 binary digits, or we are taking 4 bits or 1 nibble. Okay, this we are doing in hexadecimal. So this is from the book. Okay, convert hexadecimal A3. Either it will you will be given convert $A3H into binary, or it will be given as convert hexadecimal A3 into binary, or it can be written like this: convert base 16 into base 2 or base 10, like that. Base 10 for decimal. So convert this A3. What is A3? What is A3 into binary? Anyone?
Ma'am, 1 1 0 1 0
Hmm?
and 0 0 1 1.
Good. And what is this number? 1110 and 10000. I will show you the table. Remember, 1110 and 111 and 000.
E8.
Okay, E8.
8.
Who said that?
Rohit.
Oh, good. So here in the book also it is given like that. It is E8 and this is the answer. So we will do till here. Any doubt?
No,
No,
ma'am.
ma'am.
No, ma'am.
Okay,
No, ma'am.
all of you do one thing for attendance. Write your roll number, okay, J whatever it is, and then write your name and send in a chat box.
Ma'am, I don't know my roll number.
Harsh, na?
Yes, ma'am.
Everyone do that. First write your roll number. You are Harsha. Full name?
Ma'am, Harsh Raj.
Okay.
Ma'am, can I leave the meeting? I have
Ah,
posted in the
yes,
chat
yes.
box.
Ah, yes, you can leave. Those who have posted, they can leave.
Thank you, ma'am.
Thank you to everyone.
Thank
Thank
you,
you.
ma'am.
Thank you,
Thank
ma'am.
you, ma'am.
Harsh, your roll number is 54.
Ma'am, roll number 18. Your network is slow, so I can't chat.
Okay, 18. 1 minute.
Ma'am, what is the portion for the internals?
Hmm?
Portion syllabus for the internals.
Portion, this logic gates will be there, I think. What are different logic gates, truth table, and the symbol, and little description about it. And from this, you will get the conversion. Convert hexadecimal to binary, binary to hexadecimal, or decimal to this decimal, or decimal to hexadecimal, like that.
Okay, ma'am.
Madam, 68 roll number is okay, ma'am.
You're not able to send 68. Okay, I marked you present. Okay.
Thank you, ma'am.
Others will try to put your raw numbers in the box because it will be like a proof. Okay, that's fine. Okay, thank you everyone.